Right, hello, welcome back to another one of our motorhome vlogs. Today's going to be a bit about the van and some of the bits that I'm doing and some issues that I've had. So anyone's been watching knows that I've got the Swift Lifestyle van, and over the last couple of weeks we've been away. We've had a bit of problems with the electrical system where it's just completely shut down, only for a split couple of seconds. Everything dies, all the electronics to the heating system, the TV goes off, all the lights, and then it all comes back on again within a few seconds. So not an issue in causing us problems when we're away, but it is an issue with a fault that if it gets serious we lose everything, so that's quite a worry. And it's usually during the day, but we have had it once at night when we push the door close button on the cab, which obviously sends a signal to the sergeant system to close the front step. All the electrics went down then as well, so it's probably a problem with the sergeant main motherboard. But I have done lots of research from what I can get off the internet and found that there is a major problem with the solar panel system on the sergeant. So I'm going to have a look at that, show you that, and then what I'm doing. So let's have a look. So the system I've got is this EC400, which is the main control panel, which may be an issue. But from what I've been reading about, the main issue is with the solar panel, and the solar panel on the roof comes into here, and it's been taken out at the moment, so it usually has a controller up there like that. And I have noticed that the light on this controller wasn't working. Every now and again it would come on, but it wouldn't be on all the time. And I've done a bit of playing around, which I'll show you later on in my electronics room, and it doesn't look quite good for a controller. I've taken it out, and this is the cable to the solar panel on the roof, which is again a very cheap solar panel, and it normally then connects into these cables at the back here, which then run around to the sergeant's controller. Now, a couple of issues I've got. Number one, obviously the controller, which was spiking. I'm getting 17 to 20 volt spikes coming out to the batteries, which is probably causing the sergeant system to shut down, and it's probably the reason why I'm having that electronics issue, which is what a lot of people are saying on the internet as well. So, and the issue also, because I'm running new panels now, so I'll show you the new panels and what I fitted, and the new panels are coming over to where the batteries are. So at the moment all the connections are up here, which is a bit strange why Swift decided to do this, because this is the furthest route you can get from my batteries, and when you're looking at solar you want the shortest route possible, because the amount of current that you get from solar panels, you want to get them, you don't want the long routes where you're going to have lots of resistance with cables and lots of current through the cable system. So at the moment they're up here, and it goes all the way across the roof. I don't know if it goes around the back of the van or across the roof. I suspect it goes around the sides of the van, all the way down to this sergeant system, plugs into the back of here, which then decides where it's going to charge the, I don't know whether this one does do the vehicle battery in the back. I'm pretty sure this one doesn't, but some of the newer ones do both sides. But either way, then the current then's got to get from here all the way through past the bathroom system, which I think goes over the top again, might go under the bottom. Actually, I think it goes in the bottom, over to my battery banks, which are over here. So it's the longest route you can ever do, really, for a solar system. So anyway, so I've decided to take it out. I'll probably be taking that solar panel off as well, because I can use that down my allotment, and it's a bit of rubbish solar panel anyway. And I've got two new solar panels up there, which I'll show you how I fitted them. And they're it gives me about 240 watts, I believe, of power on the roof, which should be plenty. At the moment they're running temporarily around the outside of the van, so one of my jobs I've got to do tomorrow is drill a hole up here into the roof. It's the most daunting part of the job, which people don't like doing. Don't blame them really. One of the issues you will have is to be careful there's no cables in that area where you're drilling through. But I'm pretty sure Swift do most things like this. They put the cables around trunking bits along the roof. You see them tacked around everywhere. It's easy to do that rather than put them in the roof. But on some vans they do actually put it into the roof void between the outer skin and inner skin. So you do need to be careful that you don't end up drilling through cables. But then my solar panel cables will come down here, straight off the roof, which is about less than about a couple of foot, straight down here and then into my controller, which is right down here. And the controller I'm using down here is the Victron controllers. Most people that looked into solar panels will know the Victron controllers. One of the best on the market. I prefer them. They are more expensive than some controllers out there. They can get a little bit cheaper, but I like the fact they've got the Bluetooth system on it, which is great when you look at that. It also does the current control of the van as well, and everything else. So at the moment I've got two batteries. External battery is in this compartment outside. connected across using 16mm cable along here, so they're just paralleled up, which gives me double the amount of power on these batteries. Can't afford lithium batteries at the moment, but obviously if you can afford lithium batteries, you'd be better off going lithium, and it's a different setup than on the controller. These then go straight into the Victron control. The biggest cables I can get in there is 6mm, because that's the maximum this controllers will take, but they're protected by a circuit breaker down here, which is a 40 amp circuit breaker, so it's easy enough cable size for the amount of current that this circuit breaker should trip at. And then down here, my solar panels are coming in through here. This is the best switch I could get for the price. It's just an isolator to isolate the solar panels if I want to disconnect them for any reason, why there might be a short on them or anything, so I can disconnect them, or if I'm working on the system at all. And then that goes into here, which is a fuse, and this is a solar power panel fuse, not the same as your household fuse, because they take a different voltage as well. And then that then powers into the Victron, and then from the Victron the whole van is then feeding out of the Victron system, so that it can monitor how much current's coming out and voltage and stuff like that. One of the things I haven't done yet is put a voltage monitoring system in, which is something I'm going to be working on. I'm looking at possibly doing my own Arduino or Raspberry Pi one, or I might get off the shelf one from eBay, because there's a good one out there that's about, I don't know, £30 I think it is, or might be a bit more, so I'll look into that. So that's basically it at the moment. Batteries are bolted down when I'm finished, and they're also vented through to the floor to get rid of any gases, because these do produce gases whenever you're charging these. I've seen on Facebook forums people saying, do you need to vent them? Yes you do, because they do produce gases that can be explosive and not good for your health, but only small gases, so not too much to panic about, but they still need to be vented. So that's the basic setup at the moment. I'll go and show you the roof and what I've done up on the roof with the panels, and then we'll get drilling them cables down, solar cables coming down, and connect these into this, and then look at the current monitoring at some point. Here on the top now, I'll just show you the panels I've fitted. I've put some metal brackets in here which I bought from B&Q's, which are quite easy, just normal steel brackets with holes that I've had to put through. And these are coach bolts that I'll show you in a minute, another video of how they grind these down and slide these into this runner, which connects it all up onto my roof bars. If you've got roof bars, this is quite a handy way of fitting it. And the reason for that is that it gives a nice airflow underneath the solar panels. So one of the reasons why solar panels stop working or give a low efficiency is two reasons. One of them is the heat. If they get really hot, they don't like to work so much. The heat causes more of a resistance to electron flow, and so you get problems with low efficiency. And that's one of the reasons why the stick-on panels, which I've used before, have been really inefficient, and they don't last very long, the stick-on ones, because they break down with cracking off the cells with the heat from the roof. So you imagine these roofs get extremely hot in the summer months, especially in Spain. And the other one, this panel that I'm using here, which is the Renogy, which was recommended by Prowse. Hopefully I mentioned his name right. I'll put a little link below of his, because he's an excellent guy who knows a lot about these solar systems, and the reason why I use him as well is that he's got the equipment to test it all, and he's put them under quite a good testing system. And so these panels, as you can see, I've got 4 buzz bars. These metal strips here are your buzz bars. I think it's 4, 1, 2, 3, 4, 5. Actually 5 buzz bars, even better. I think I've had 4 before. And the more buzz bars, the better, because it reduces the amount of resistance to current flow again. And so you're trying to get as much current out of these cells as possible without any resistance to current. So the more buzz bars, the better. And as you can see, I'll just lean over. This is the old system of the Sargent one that you get with the solar panels with the van. And as you can see on these, you've only got 2 buzz bars. So it's a very low efficient panel, which is one of the reasons why we're getting low power out of it. And to be honest, I probably will be taking this panel off and put it down my allotment rather than trying to connect this back up again. And if I have problems with power at all and I think I need more power, I'll just put another one of these big Renogy ones on, because I've got enough room up here to be able to do that. Right, so back inside the van there, you can see it's the hole that I punched through the roof. Like I say, you've got to be careful with holes going through. I went through a small drill bit first, making sure there's no resistance, had the batteries disconnected just in case. But I don't believe there is any wiring in the Swift system within the panels and the roof, and you probably could check this out if you want to get in touch with them. It's quite a big hole because I might bring other cables through if I don't run another solar panels, and I don't have to retake all this out and drill a hole through. So that's the main thing. The most worrying thing about fitting panels on the roof is getting that seal on that roof. But the amount of stuff I put on there, and I'll show you the adhesive I'm using, which is a caravan adhesive for roofs, which is a flexible adhesive, and it allows it to move with the heat, and it doesn't completely set. They don't use silicone or anything similar to that, which sets solid and it cracks and breaks up and will leak. So a lot of people think silicone's the best thing for external windows, and it's not, because the roof moves, there's movement on the roof. Right, as you can see now, I've finished fitting the solar panels and everything's back to normal. I've boxed in the top corner like I said I would, and I'll probably get some sort of battery monitoring system up there maybe in the future. And then all the trunking put in for the cables to go down into the Victron system, and all the beds back together. So that's the solar panels finished really for now. But I'll just show you, just log into my phone and I'll show you the Victron app that you can get. I'll just come out of this. So when you download Victron app and you get the little icon, you click on it to log in, it's going to connect straight away. And what you normally do is you get this page here where it should pick up your device, and when you click on that button there, it usually asks you for a pin number on the first attempt, which is standard to be all zeros pin number if you've never used it before. So I'll click on that and it'll connect now by Bluetooth to my solar panels. And so this is the main display. It gives you the wattage that you're getting out the panels, which today is absolutely chucking it down. There's no sunshine and it's all clouded over. So this is a typical bad day for solar, and it reasons why people with low powered solar panels will get very low on a good day, and on a bad day with even 200 odd watts I'll get nothing. So it just shows you that solar is only good as the sunshine is out there really. But it gives you the voltage coming in. I'm getting 18.2 volts coming in from the panels still, even with no power. And it just shows you why that current, what I was talking about, current length of cables, the dimensions of cables, and everything that resists current flow, you've got to reduce as much as possible, because even with the voltage there, we've still got no current coming in from the panels. This app gives you your battery voltage. My batteries are sitting there at 13.69 volts, which is quite good, but that's purely because I've got my mains connected up and it's running. I'm running on the charger really, because the van's on mains. And although I've got my lights on, and I'll turn my my TV stuff on just to give some more power to the van, put it in the van, you'll see on here that I'm pulling no current, and the current output load is 0 as well. And this is purely because I'm running, like I said, on power from the charging system of the van. And you see it's gone up to 14.3 volts there, which is strange. It should have been showing that first really, because like I say, I'm on mains. But the app also gives you a history. You can see yesterday I was putting 90 watt hours. It wasn't a great day yesterday either, and I got yield 90 watt hours of yield. That means 90 watt hours of power into my batteries, and I consumed at the bottom, where you can see that, 70 watt hours. So in total I gained 30 watt hours yesterday. So you could sit here and calculate this each day to work out what your battery levels are, and it goes back quite a few days. If I go back to 15 days ago, I think, 15 days ago I pulled 260 watt hours of yield, and I used 50 watt hours, so I did really well on the amount of power that got into the batteries. And the day before that, 14 was 360 watt hours, 100 watt hours of yield I used, so I got 260 out of it. So it's quite a good little app, and I haven't even explored some of the other top bits. Don't know what the settings are. It's got a share button there and a timer button, so I don't really know most of that. Lifetime total, I'm assuming if I set it up properly it might give me my total, what I'm getting out of it at some point, I don't know. And it's got a trending part here which I haven't looked at either. So there's quite a bit to look at on the app if you want to get into your batteries and see what's going on. But obviously a battery monitoring display is quite handy, because you can actually set it up to your batteries, say exactly how much amp hours you've got, how much amp hours is going out and how much amp hours is going in, and then be able to work out a percentage of how much power you've got left, just out of interest. Right, so like I say, it's pulling no current at the moment. So what I'm going to go and do is turn off my mains charging system. So on the, if you've got a panel, some people got panels on their vans, mine's this one, and that's a charging button. So if I click that now, so it's not charging the batteries now on the van. So we're purely off the power on the van batteries. You can see there, oh, I've just got 2 watts of power. So that's what I'm getting out of these power at the moment. But you can see down here now, it says the current consumption is 2.7 amps. Minus 2.6, 2.7 to the batteries, which is about right. And what I'll do now is I'll just turn the telly off to see whether that changes. Right, so the telly's just gone off, which has gone down to 1.6 amps now, put the charge. And if I turn my other power supply off thing that I was using, which powers up my little TV amp, I'm still 1.4. I've still got lights on, and I expect my router and everything else is running. So that's the sort of current I'm putting in at the moment on a miserable day. So anyway, that's the end of this video blog. That's showing you how I set up my solar panels for now, and how the Victron system app works, which is a pretty good system for compared to a lot of the others that are out there. Anyway, that's it for now. That's my solar panels all fitted and running, and hope it was of some help to some people. There is some good videos, blogs out there. I say Will Powers is a brilliant one to watch if you want to learn about solar and stuff. And I'll put a link in for him. So if you want to learn anything about these different controllers or different panels and cable links and all the rest of it, he's the guy I think to go to. So I'm going to upload this. Hopefully you enjoyed it. Give us a thumbs up and subscribe. I'll do a little video blog of all the other mods that I've been doing over the last week on the van, little bits and pieces. If anyone's got the similar sort of Swift van. And then the end of the week we should hopefully be off on our little weekend away, bank holiday week, not bank holiday week, half term week, because the schools are breaking up. We'll be off down to New Forest, so we'll update you when we're on our way down there.